How about now? Yeah. Oh, I hear an echo now. Okay, great. I'll ramble on for a minute, I guess, to give more people a chance to slide in. Does anyone recognize what this is? It is, according to a 1-minute Google search, so may be incorrect, one of the 2 statues that Shelley saw and inspired the Ozymandias poem. So we're talking about long-term maintenance, and this is something that fell over. Just thought that'd be appropriate. Anyways, I'm very excited to give this talk because I had an idea for this maybe like 2.5 years ago, and then something happened that made it impossible to give conference talks for a while. So here it is, something that's been stewing in my brain for a couple years, about maintaining software correctness, which I think could mean a lot of things to a lot of different people, so I wanted to kind of ground what I'm talking about in an example. I worked for many years on the Trello Android app, and in that time, we switched to using RxJava at some point, or stream-based APIs. And before this, we didn't have any problem with memory leaks in our event systems. You'd have a button, you'd set up a click listener, when you click the button, something would happen. When the button would go away, when that would get garbage collected, so would the click listener. That automatically disappear. With RxJava, when we adapted it, you would subscribe to a stream of the button's events. And because of the way that RxJava worked, it was no longer a one-to-one. Like, the button would disappear, but the stream would still be set up, and it could possibly leak memory if you did things incorrectly. So I didn't really like this. I didn't like the default RxJava answer where you have to like hold on to this subscription object and unsubscribe from it manually, because we could possibly have hundreds or thousands of these in our application. And so back in the day, I wrote a library called RxLifecycle. I have since disowned this library because it was not very well written. There was a whole bunch of problems with it. I wrote a whole blog post about like all the things that were wrong with it. It was a big learning experience for me. But one of the things I actually didn't touch on in the blog post was something around human fallibility. So in order to use RxLifecycle, we'd have something called an observable. By the way, if you don't know RxJava, it doesn't matter at all. This is just a very short code example. This is the only code in the entire talk. You'd have this thing called an observable that can spit out a stream of data, and you'd call subscribe to it at some point. And we had stuck in this method called bind to lifecycle. And what that would do is it would say, OK, while this button is on the screen, you can get the events, and then we can automatically detect when the screen goes away, and when that goes away, we'll automatically unsubscribe. But there were 2 big problems with this that I didn't really anticipate. And it was that if you would ever forget to actually call that, you would leak memory. So we created this library to prevent you from leaking memory, but you still have to remember to actually call this. And remember, I said that this line of code happens like hundreds or thousands of times. And just depending on people to do it right, just depending on people to always remember to add this line of code was not going to work. Someone was going to mess up at some point where you're going to leak memory. Not only that, there was also this subscribe on and observe on calls that happen all the time. And it turned out that like if you didn't call bind to lifecycle after those, if you called it before those, it also might not work correctly in some cases. So again, just another thing, you have to remember, always call it after your observe-ons, before the subscribe, or you might leak memory. And so this led me to realize there's this correctness dilemma in so many things that we write. New architectures we develop, new APIs we write, new libraries, new team processes, where it is very, very easy to create something like RxLifecycle, where it's supposed to help us out, but it's very hard to maintain people using it correctly over the long term. So like a few more examples of that besides the RxJava memory leaks, there's like maintaining code style. You want to do tabs versus spaces. How do you make sure that that is something that's implemented over a long period of time? How about contributing to an open source software code base? How do you make sure that everyone is contributing in the same way and keeping the code base healthy? How do you consistently release builds? We had like a release train going. How do you make sure that every step in that release train happens every time? And the mistake that I made for much of my career, probably at least 10 years, was simply not thinking about this problem at all. I would think about maintenance in terms of like how easy is it to update code over time. But I wouldn't think of it in terms of like, how do we make sure that something which was correct at the start remains correct 2 or 3 years from now? How do I make sure that something that I wrote for other developers, that they will actually keep using it correctly for years? And Now what I think about a lot is making sure to design for human fallibility. That's the one joke in this whole talk, so there you go. I hope you enjoy that. So before, if you pay no attention to this problem, maybe you'll get lucky, but like things tend to fail over time. Now I've found that in the past couple of years, I've paid a lot more attention to how something I write is going to be used over the long term, and it can still get messed up, but more often than not, it actually does go correct over time. So there are two big ideas in this talk that I think kind of drive all of my thinking around this. And it's obviously not a new problem that humans make mistakes. People make mistakes all the time. I'm going to make at least 5 of them giving this talk, where I'll say, actually, that was a bad example, take that back, and try to stick out another example before you remember what I was talking about. Just like that one. So, but I think that in software, there's a particularly unique thing we can do, which is that we can turn human processes into software processes. And that's true of a lot of places. But since we are the actual software developers, we're very close to that ability. And that is one way in which you can get correctness. And the second big idea that's going to run throughout this talk is that, in general, the less freedom that you give to people, the more likely that they're going to do the correct thing. Because if they have the freedom to do anything they want, most of the options they choose are going to be incorrect. If they only have the option to do one thing, and that one thing is correct, then they're going to do the correct thing every time. So with those 2 thoughts in mind, I'm going to run through a bunch of strategies I've thought of. There could definitely be more than these. I am not claiming to be an expert on this. It's just something I've been thinking about a lot over the past couple years. So here is the 6 topics I'm generally going to be going over. And I like to think of them on the spectrum from flexible to rigid, where the most flexible things are the least likely to be correct over a long period of time, and the most rigid things are the most likely to be correct over a long period of time. So let's just step through these one by one, starting with institutional knowledge. And what I mean by institutional knowledge is just stuff that's in your head. The good about institutional knowledge. Well, obviously, everything starts here. Every idea has to start somewhere. Software doesn't write itself. Even code generation has to start with someone writing the code generator. So obviously, this is something that's necessary. It's extremely cheap. You can go to a brainstorming session. You can come up with 30 ideas in 30 minutes. That's really, really cheap. You can't implement 30 ideas in 30 minutes. That's like 2 years of work. So very, very cheap. Extremely flexible. Maybe you can go to your team and say, I feel like I don't know enough about what everyone else is working on. Let's post like a daily status update in Slack in the morning or something. And then you do that for a week, and everyone hates it, because everyone hates daily status updates. And so you say, we're going to stop doing that now. So very flexible if you just tell people things. You can explain and summarize ideas. So one of the big architectural things that we wrote into the Trello Android app was the ability for the app to work offline. And so what we'd do is you would do something like creating a card. We would write that to a database, and then that database would contain a bunch of rows of what information we need to sync to the server, and then that would sync with the server eventually, and we get to parity between what the server and the client thought. All right, so I just explained to you what 10,000 lines, probably 20,000 lines of code does in a couple sentences. So that's something pretty cool. You can explain, summarize, you can explain the whys or hows of things. Like if you have some particularly horrific hack somewhere in your code, you can explain, I tried everything else before this, trust me, this is the only way to make it work because of how the Android view system works or something like that. You can use institutional knowledge to describe human problems. So your vacation policy, it's not something that you can necessarily write in code when someone's going to take vacation or what exactly they're going to do on vacation or all that stuff. Some elements of it you could have your workday system allocate a certain number of days off or something like that. But it's still, there's usually steps where it's here's our listed holidays, here's a process of requesting vacation. That's sort of something you have to know, not something you just write in code. But there's obviously a lot bad here in terms of correctness. So what can go wrong? Things can be misremembered, forgotten, or just leave. I don't know how often I've forgotten my own things. There was one time I was working on a problem with Google Maps, and I Googled, type in the keywords of my problem, and I found an answer on Stack Overflow that was the perfect answer to it. And the person who had written that perfect answer to my problem was me. Like 3 years in the past. So you can definitely forget things. People can leave a company, and all that expertise just walks out the door. It's laborious to share. Telling every new person about some piece of information, that's a lot of work. They might not remember that, so you have to keep telling them over and over again. It can be really hard to communicate. I don't know if you've heard of this game called Telephone. It's just about being able to talk to people and not have that message confused. Like, that game is fun because it's hard to just tell someone a sentence and have it go from person to person to person. Very hard to communicate in general. No reminders. This is a big problem with correctness, which is that there's often things that have to be done on a regular basis, and institutional knowledge does not in any way remind you that you need to do something. If in your release process someone needs to press a particular button every day to update the rollout percentage, let's say, that you can't remind someone in their head. They might go on vacation and no one else remembers that's something that you're supposed to do. So institutional knowledge, it's a good place to start. It obviously, everything has to start there, but if you want to have long-term correctness, it has to graduate from here at some point. So going from that, the next natural step is documentation, which is basically just all of what I just said, but written down instead. So that makes it harder to forget, because now it can't just leave the company or be misremembered, and it's a lot easier to broadcast. There's a couple other benefits from documentation, which is that you can use visuals. For example, the offline sync architecture, there's a particular way that data flows from the UI to the database to the sync server. And I could get up here and talk about it for 5 or 10 minutes and try to make you understand how the data flowed, or I could show you one flow chart and you'd probably get it in 5 seconds. I think that's also the reason why video essays have really taken off in the last decade, is because people have realized that just articles usually aren't enough for some concept. It's really nice to be able to talk and also show images at the same time. You can create checklists for very complex processes. There's a whole book, Checklist Manifesto, that came out a few years ago about this, where essentially anything that has a whole bunch of steps, if you create a checklist and you remember to check that checklist, there's a lot more safety involved there, because it's a great reminder to have a checklist to make sure you're doing every step of the process. So for example, when we were doing releases, there were still a lot of steps that you had to do manually, for example, writing release notes. And just having that checklist there to remind you, hey, by the way, someone has to write these release notes, helps a lot. But there's a lot of bad about documentation. And in fact, the original genesis of this talk was the idea that documentation is not enough. Because I kept seeing this pattern happen over and over again within my team, which is we would go through the institutional knowledge step, we'd come up with some cool idea, we would all agree that this was a cool idea, and then someone would be like, we need to write this down. We need to write this down so that no one ever makes this mistake again. And we'd write it down, and then people would keep making that mistake. Because documentation is not enough. There's all sorts of problems with documentation. It can be badly written or misunderstood. Not everyone's a natural writer of technical documentation or human process or whatever. It's very easy to miscommunicate it. It even is worse than institutional knowledge in some respects, because when you're talking to someone, you can ask clarifying questions. If you just come up to some documentation, you often can't. And in fact, that was why, I remember back in the day, Android used to have pretty terrible documentation. So I'd go to these Google I/Os in 2010, 2011, and go and talk to the actual Android engineers. And that was so valuable, just because I realize now I could have a back and forth conversation about what the hell the documentation was even trying to tell me. It's often poorly maintained. Whatever you write today can go out of date tomorrow. And it's very hard to remember to go back and update that. It can be hard to find or just ignored. How often has this happened to you that, let's say, for example, that for your network calls, you're supposed to draw from a connection pool so that you don't create too many connections at once. And some new person joins your team, and they don't use a connection pool. They just start up some connection and start connecting to a network call. and someone's like, hey, why didn't you read this documentation saying you're to use a connection pool? And their answer is going to be, because I didn't know that documentation existed. They didn't even know that they needed to go out there and find that knowledge. Or it can just be ignored. Someone can be like, the connection pool is too hard. It's too hard to get that object out of like the object graph in this particular spot. So I'm just going to make a connection and hope nobody notices in code review. No reminders, again, same with institutional knowledge. Like the checklists are very handy. Still, you can ignore the checklist, and this also happened, like I said, with the release checklist that we used to have. It would have all the steps you need to do, which is great if you remember to look at the checklist. But the number of times where someone would be like, oh, shoot, I forgot to look at the checklist on Thursday when I was supposed to look on it. Now it's Monday, and now we don't have enough days to actually like translate our release notes. So all sorts of problems with documentation. Let's do even better than that. Let's go to affordances. Now we can see the magic of magic move. For some reason, every other animation in this deck is good, and this one, the F's get all messed up. I have no idea why. Let's just look at that again. Oh my goodness. Anyways, magic move is amazing. So affordances. This is an idea I got from The Design of Everyday Things from Don Norman, pretty famous book. The quality or property of an object that defines its possible uses or makes clear how it can or should be used. So a classic example of this is how doors are set up and whether a door is easy or hard to use. So here we have what are known as crash bar doors, and it's really obvious how to use this door. Like, you push it. You would have to go way out of your way to like grip onto it and try to pull. Everything about this door is begging you to push it, and it's super intuitive. On the other side, you have what are known as Norman doors, named after Don Norman, who wrote The Design of Everyday Things. This is a door with a handle, and like, what are you going to do? You're going to pull it, because that's what that handle is asking you to do, naturally. But actually, the sign says push. And I don't know why in this picture. Why did they not just remove the handle? Because they have that big flat piece of metal. That would have been good enough. So what is an affordance, essentially? It's like, if it's a way to invite someone to do the correct thing with whatever you're giving them in this context. So what does that mean in terms of software development? I like to think of this as creating affordant APIs that can invisibly guide people towards the correct thing to do. So for example, we would create, like when you wanted to create a card in the Trello Android app. In the old days, you grabbed a connection to the database, and you wrote SQL to write to the database. And then you made sure to go out to any possible UI that might have been showing that card and make sure to go update that UI. And then you go make a network call and all this stuff. It's a huge pain in the butt. And eventually replace it with a single line of code that went and did all of that for you automatically. And that was in that single line of code, we replicated for basically any change you would make within the app. And like, can you imagine what people used? They didn't go directly to the database after we got that all set up. They would use the modification system because it was so much easier. And that was the thing we wanted people to use anyways, because along with just doing the thing they wanted, it would automatically apply things like analytics. It would automatically be able to work with like the offline sync system and multi-user stuff in ways that if someone were to be doing it manually, they might mess up. So I really love this idea. This is like, affordance is in the middle of these correctness strategies, but this is like my favorite strategy of all, because you're not telling anyone what to do, you're just giving them two options, the easy way and the hard way, and people naturally take the easy way. Likewise, you can make things unaffordant. You can make things really hard to do when you need to add some exception handling, like in some rare cases, people need to do something else, but you can make it deeply uncomfortable for them to do that. And then they will naturally steer away from that unless they have to do it. I've actually gone to the level of having dummy parameters on function calls, where it's just like, it's a Boolean, where the name of the Boolean is like, I agree that I've read this documentation, basically. Like, I understand that this function is dangerous, and you need to read the documentation before you use it. I couldn't figure out any better way to like give you this heads up that this is a dangerous thing to use. Maybe not the best pattern ever. I try not to use it very often, but it works. It's sort of like how governments can sort of like push people in one way or the other through subsidization and taxes. Like if you subsidize something, people are going to use it more. The cheaper something gets, people use more. If you tax the hell out of something, people are going to use it less because it costs more money. Another sort of way of pushing people in the right direction visibly, this is not an affordance, but I couldn't figure out any better place to jam this into this talk, is the idea of existing code creating this peer pressure, where if someone asks me to add a new button that makes a network call, the first thing I'm going to do is find somewhere else in the code base that adds a button that makes a network call and copy and paste that code and then just modify it for my own whims. And if you have 50 different ways to have a button make a network call, I hope that I picked the right one. If you have one way to do it, then you're always going to pick the right one no matter where I copy from. And so there's this kind of peer pressure that's created through existing code. So I love all these concepts of like invisibly guiding people towards the correct thing. The only problem is that they can only restrict, not guide. Sorry, they can only guide, not restrict. Like you can't restrict someone from doing the wrong thing, you can just guide them towards doing the right thing. But if you do it right, people don't notice that you've done anything at all. Oh man, that animation is also terrible. All right, anyways, software checks. So this is basically the idea that code that can check itself. And the first thought that probably jumps into your head is unit tests. And I am sort of talking about that, but I'm talking about a lot more than just unit tests. I'm really talking about any place that your software code can check itself. And the timing matters here a lot, because the faster you can make this feedback loop, the better. Like some feedback loops can be months long, and some can be seconds long. And I'm going to run through all the different timings from the longest feedback loop to the shortest. In one moment. So runtime checks. This is definitely the slowest. These are checks that are made while your code's actually running. You've compiled, you're executing. So an example of this might be, you can check practically anything with this, which is why it's so useful. An example of this being we use this library all the time called OKHTP for network calls. It has a stateful class called a call, and because it's so stateful, they don't want you to make more than one network call with each object. They want you to create a new call per network call. And so if you try to make two network calls with one call class, then it blows up in your face. So you can check almost anything with runtime checks. The problem is your users might end up being the testers. And this really sucks when, like, say you checked in the bug today. It goes out to your users 3 weeks from now. They start running into the bug a week after that, and it's another 2 weeks before you can release it. Like that your feedback loop can be absolutely humongous. You might not even at that point realize that the change you made like 4 or 5 weeks in the past was the thing that's causing the problem for the users. So it's something to use as a last resort. Like, don't get me wrong, my code bases are littered with runtime checks because I want to know as early as possible when I've broken my own invariance. But it's not the ideal. The next step up would be manual checks. So this is the unit tests, the integration tests, the regression tests, all that stuff. Huge, wide range of testable logic. If you set up your code base right, you can test almost all the same things that the runtime checks would do. That in a dream world, of course. In the real world, it's much harder to do this. These are great. You have to kind of foster a culture of testing for them to actually work, though, because the problem is that, like, you have to architect for tests. I think this is a good thing. When you architect for testing, it makes your code base generally better, in my experience. But it does mean that, like, everyone has to be keeping this in mind, that, like, if I want to be able to add manual checks, I have to be able to architect in the right way. It takes time to write tests. I'm sure test-driven development people are upset at me for saying that, but it does take time. I think it does pay off in the long run, but up front, it can cost more. It takes time to verify that your test was actually correct. You can write tons of tests that don't actually do what you thought they were doing. So if you can get this culture of checks going, huge benefit from this, especially if the architecture supports being able to test most layers of your application. The next step up from that are automatic checks, where that's just manual tests that are run on their own sometimes. Because manual checks are great, but if you forget to actually run them, they aren't that much help. Whereas if you have continuous integration, and it automatically runs your checks every once in a while, so much better. Yeah, just not much for there. Next up is compiler checks. So this is like the compiler enforcing its own rules during build time. So like a classic example of that is like if you have a statically typed language, it can check that all the types are correct, that you're not passing a Boolean where you should be passing a string or something like that. But it can go beyond the compiler. You can integrate all sorts of things into the compile step. You can integrate code style checkers into your build. You can add lint checks into your build. code coverage stuff. You can even have some manual checks run during your build. Like if your unit tests are fast enough, you can have it run at that point. And then the fastest, which is something I didn't even think about until someone pointed this out when I was talking with them about these software checks, is design time checks. So this is actually even faster than the compiler. And this is where your editor itself checks for things being incorrect. So if you are running, say, IntelliJ, and it can like show up stuff like, hey, you were supposed to pass in a non-null string, but you passed in a null string. Or like, this function takes 3 parameters, it only takes 2, and it shows those little red squiggly lines, and you have this instantaneous feedback that something has gone wrong. So that's really cool, because it's immediate feedback. It's still not actually limited just to the compiler. You can still integrate things like code style and lint into this step. And in general, the software checks, like I said, the faster feedback, the better. If you are instantly told that you're missing a semicolon, you fix it and you move along with your day in like 5 seconds. If you have to wait until the compilation step, maybe the last time you compiled was 5 minutes ago. Now you have to go back to like that line of code you wrote 5 minutes ago to fix that semicolon. If it's at runtime, maybe you have to wait weeks before you find out that something went wrong, and it's hard to debug. The only downside with the faster feedback is it tends to be more constrained in what you can actually check with it. Whereas runtime checks, you can check just about anything imaginable. When you're talking about design time, you're very limited in what you can actually do in that quick amount of time. Next up are constraints. So this is just the idea of making it impossible to do the wrong thing. So a few examples of this. You can have enums instead of stringly typing. So stringly typing is very tempting when you're dealing with, say, with JSON from the server. The JSON sends back some sort of type field. You have cards, boards, and lists. And you're like, great, it's sending back a string. I'll just store it as a string. But now you've created a spot in your database that can contain any string whatsoever. Even though the API is only sending you one of 3 things, you now have to deal with the possibility that anything could be in your database. Whereas if you have an enum, then you're limited to just exactly the few things that you're expecting. One tip here, by the way, if you use enums, definitely add in a 4th case that's unknown if you're like parsing server stuff, where you can just throw anything you don't understand to unknown and maybe like notify yourself that something weird came in. Because if you don't do that, then the server is going to have a real hard time updating without crashing your client. Another example, stateless functions versus stateful classes. So if you have a pure function that just takes some inputs and spits out an output, that's not very complicated, as long as there aren't any constraints on like what sort of inputs you can put in, then it's like the only thing you can put into this function is the correct inputs, essentially. If you were like, I don't know, some Fibonacci function, it takes 2 numbers. You input 2 numbers, it spits out another number. You can't really screw that up too badly. Versus a stateful class, like OKHTTP's call class, it can't be made to do 2 network calls at once. It's very easy to mess up a stateful class. Once you have state, it's always possible to have the different pieces of your state mess with each other and get angry at each other. Another example is pull request versus merging to main. So if you just let anyone merge to main anytime, they can do all sorts of things, like check in a bug that would crash your manual checks. You can have things break the code style. You can have people check in I don't know, malicious code without anyone else realizing. Versus if you gate people behind pull requests, you can have all these continuous integration checks. You can say that, oh, we need people to have code reviews. We need people to have pass code style. We need people to pass all these manual checks. So I like constraints a lot, again, because it's another sort of invisible thing that you can do, where you're saying people don't even have to think about the other possibilities. The only possibility is the correct thing. And as an added bonus with constraints, it limits your headspace too. Like again, with the enums, now when I look through the code, I'm like, OK, I have 1 of 3 possibilities, and that's it. I don't have to think about all these possibilities. Or when I'm writing test cases for it, I only have to write test cases for 1 of 3 things. If you have a stringly typed object, in order to really do the correct test, you'll always have to have 1 test that's like, here's some garbage string. How does my app deal with this garbage string that I wasn't expecting? All right, and the last one here is automation. So this is no humans involved whatsoever. So a good example of this is code generation. So in Java, you can have these things called plain old Java objects, basically your structs of the Java language. And the problem with them is that you can't tell whether 2 of them are equals off the bat. You have to write your own custom function to be able to tell you whether 2 objects are equal to each other. And it's very easy to get this wrong. And even if you have something that generates those equals functions for you, it might go out of date. You might add a new variable to your plain old Java object, and now that thing's wrong. Whereas now there's a bunch of tools for code generating these equals functions. So you can have this auto value library does it. There is Kotlin's data classes automatically generate it. So now there's no humans involved with the creation of the equals function. It's just correct. Continuous integration. I want all of these. I want the code style checker to run. I want the lint checker to run. I want the manual checks to run. It just automatically happens. No one has to get involved. Automatic deployments. I've been working in the Android world for years. That's never going to really happen for me. But it's very cool to me when I read about like web deployments where they're just like, yeah, the moment we merge to main, it just goes out. So write once, run over and over and over again. It's a huge time saver, it's not just a huge time saver, but also it's a good correctness thing, because as long as it's correct in the first place, the automation, then it's just going to keep reapplying that correct thing over and over. The only problem with it, it's a lot of effort, usually the most effort by a long shot, to do this sort of automation stuff. All right, so those are all the strategies I've been kind of thinking about. Let's see how we actually apply that to any given problem. So when I am solving a problem nowadays, I also think about the long-term usage of it. The most recent thing I can think of was I was working on some like instrumentation project, and it was like adding instrumentation to network calls. And I was thinking about like, okay, it's pretty easy for me to add this instrumentation to the network call, but how do I make sure that like 2 years from now people are still actually doing this and still doing it correctly? And when I was thinking about it, it's like, okay, I can add checks, I can add runtime checks to make sure they're setting up correctly, I can add constraints so that whenever they opt a network call into this instrumentation, the IDE essentially tells them, like, here's all the stuff you need to fill in. So from that perspective, too, not only do you have to think about this, but you also have to mix multiple strategies together. You don't have to, but you tend to do that. Like, when I was listing out the correctness strategies, I'm not saying, like, pick one of them and go for it. These are all just a rainbow array of things you can do. So with that in mind, there's a few caveats I want to go over when you're looking through this. When you're picking your correctness strategy, rigidity gets you correctness, but it costs you in flexibility. Like I said, institutional knowledge, very flexible, very incorrect. Automation, very correct, very rigid. It costs a lot to change your automation. So you really have to think about what your balance of flexibility versus correctness is going to be. Like, I actually tend to opt towards flexibility to start, and then as I realize that things are going wrong, then I start to add more and more things in, move it down that ladder and get it to a spot where people aren't going to be making mistakes long term. You can implement correctness badly. I keep alluding to this, but like, if you mess things up, nothing will save you here. So like, you can have flaky software checks. Who's ever had a unit test that fails on them every other time? You can have a contribution process that's so constrained and annoying that people stop contributing to your code base. Your automation can be extremely annoying. I mean, who's had a build that breaks, a CI that breaks, and it takes like a week to get it back up and running again, and in the meantime, everyone's upset because nothing is working. Or you could over-constrain your API such that like management comes to you a year later and says, hey, we need to add a new feature, and you realize like, oh no, I can't do that. Like, classic example of this being instrumentation to me, because every time you write a beautiful API, then some manager comes to you and says, I would like to find out how many times this API is being used or how exactly it's being used, and you're like, shoot, now I have to pass this instrumentation like jerk along with all of my functions to make sure that it works, and it's like this little instrumentation object messes up all of my beautiful APIs. So you have to make sure that the costs are worth it, because it tends to be that the more rigid you get, the more expensive it is, especially if you make mistakes. And then last but not least, when considering these things, is that you really need to get team buy-in on whatever you're doing. There is a very social aspect to correctness. It makes it so much easier to do any of these steps if you actually get everyone to agree with what you're doing beforehand, because they can suggest ways to make it better. Me as one person can come up with all these ideas of like how I would do something correctly, but it turns out other people's minds work differently than mine. I don't know if you've ever realized that before, but like everybody thinks a little differently. So it's nice to have a whole diversity of opinions about like how to actually solve this problem for long-term correctness. And then the opposite, if people don't like what you're doing that leads to toxicity, and people will actively undermine whatever you tried to do. Like the first job I was at, we tried to implement this code style. Like this is a code base that had been around for like 15 years. We tried to add a code style checker that would basically on git push block you if whatever files you edited didn't match the code style. And there were some files in this code base that were like 10,000 plus lines long. And so no one wanted to be the person who had to go through those 10,000 lines and fix every single line of code, because it wasn't something that could be automated, because it was like this custom language that only existed for the company. And so inevitably, everyone kept using this escape hatch they built in, which allowed you to send a special command to Git to avoid the code style checker, which completely nullified the whole code style checker, because they would just use it every single time. So you really want to be able to make your case. So like start with some experiments, then bring the evidence to your team, verify that they actually think this strategy will work. All right, I want to finish off going through a few examples and like how I think about this problem in those settings. So let's start with code style. If you need something more solid, like tabs versus spaces, let's say. Institutional knowledge, the worst. You can tell people, but there's so many different aspects to code style, it's gonna fall over immediately. Same with documentation. Like it's useful to have documentation about how your code style should be, but it will not guarantee correctness over the long term. People will just ignore it or make mistakes. Affordances, big thumbs up for me here, because for example, when we're using IntelliJ, you can check in a code style XML, and then that code style XML, everyone would be using the same code style. And if you ran the auto formatter, it would format everyone's code the same way. That just made it easier for everyone to stay on the same code style. Software checks, definitely the #1 answer here. If you really care about your code style being correct across all of your files, have the software check it for you. Like as an added bonus, when the software checks it for you, people don't get annoyed. If you have someone who's going through every code review and nitpicking every code review, trying to like find where you used a tab instead of a space or where the parentheses isn't on the right line, you will quickly become like the least popular person in the workplace. Whereas if a computer does it and CI just tells you got something wrong, no one gets mad. And then I don't know how you do constraints and automation for this, because like code is just something you're writing down. I'm not sure how you constrain someone from like, I don't know, tear the tab key off of everyone's keyboards. Not sure. All right, contributing to an open source project. Institutional knowledge does not work at all, because we're talking about strangers showing up and trying to contribute code. You're not even going to be able to talk to them before they start interacting with your code base. Documentation, definitely something worth looking into. You know, you have to make it pretty clear. It's definitely not the big winner here, but you know, a good documentation of like, here's how you start, here's how you contribute. There's become a pattern of having a contributing.md file in a lot of open source code bases for how do you actually start contributing code. Affordances are helpful here. If you have a bug tracker, if that bug tracker comes with a template that's like, here's the information we want to have with each bug before we can try to solve it, that makes a huge difference to you getting like high quality bugs. Software checks, very, very good for open source projects. Having lots of having a lot of automated checks that whenever someone tries to contribute code, checks that the code that they're contributing matches your code style, matches your, doesn't break any of the old functionality, definitely needed for like any big open source project. Constraints are very good here too. You don't want every person on the planet to be able to push to main on an open source project. So of course you're going to limit that to like maintainers. You can add checks where it's like, before any code can be merged, it has to be approved by some number of reviewers, or it has to be reviewed by a certain maintainer. You can add all that. Automation, you need the automation on some level to like have it run the CI essentially. So this is an example of something where you're taking like a whole smattering of strategies to solve the problem. All right, and then to get back to the example that I started this talk with, this is where you know, we start the talk with one example, and then here's where you solve it. This is what they call the prestige. Institutional knowledge did not work. Documentation did not work. Just telling people to make sure to clean up their memory leaks doesn't help. No one wants a memory leak. They do it by accident. Affordances. That's essentially what RxLifecycle was trying to do. It was trying to make it easy to avoid leaking memory. It didn't quite work, but with RxJava, there's not much better that you can do than that. People have written better versions of RxLifecycle now. There's something called autodispose. Still requires people remembering to call that code, but you can sort of do that. You can have software checks. There's a library called RxLint that makes sure that you're kind of cleaning up memory. Not perfect, because it can't guarantee that you're actually cleaning it up when you need to clean it up, but it does check the basics of it. Constraints. This is the really, really, really cool thing that Kotlin coroutines does. So we switched from using RxJava to Kotlin coroutines in the past few years. The Kotlin coroutines in particular have this idea of coroutine scopes. And all of its concurrent work lives within a scope, which means that when that scope expires, all the work within it expires automatically. And that is an extremely cool way to make sure to clean up and not have a memory leak. And here's the real kicker about their scopes. They're not optional. You are required in Kotlin coroutines to use a coroutine scope if you want to launch a coroutine. So by default, no matter what you do, there's always a limited lifecycle to whatever you called in Kotlin coroutines. So that's a really cool answer where they can skip the affordances and software checks and just be like, we're forcing you to actually use these constraints. And then I don't know how you'd automate this, because there's no way for some library to know when you've stopped using some stream of data, basically. All right, that was all I had, which is good, because I think there's only about 3 minutes left. Thanks. If anyone has any questions, we got like a few minutes. Yeah. So the question is like, when do you decide to refactor, essentially? For me, I've always thought of this equation in my head of like, what is the cost of continuing to use this thing versus the cost of refactoring it plus minus the time saved or something like that. So it's not. I think of it as outside of the correctness thing, basically. I always think of that equation. Like, what do I predict will be the long-term win there? I don't know. It's one of those problems where it's like it's so qualitative. It so depends on the particular judgment of the engineers in that particular problem. Because if this is something where it's like, oh, this thing messes up 1 out of 10,000 times, and refactoring it would take a month, you might be like, well, that doesn't matter. But then what if that 1 out of 10,000 times cost the company $1 million? Okay, now it does matter. It's so qualitative. You just have to think about all the costs and benefits and analyze that. Any other questions?
I was just going to say, I see a parallel to team size here. Another you're saying, there's certainly a throughput communication problem that happens with institutional knowledge and scale up with automated stuff and that. And do you find that too? And the managers on it with that idea?
Yeah, so you're mentioning that is this kind of like coordinate, like what do you say, correlated with team size, basically these problems? 100%. I think it's not a surprise to me that this is something that was more in my mind as my team got bigger. Because when you're only like you and 3 other people, it's really not that hard just to coordinate. And the same with like how your work gets done, whether you use a process or not. Because in my mind, process is just what you do in order to solve the communication problem. Like if it's you and you alone, you don't need a process because you don't have any problem communicating with yourself. If it's you and another person, you can just hang out in the same room and like talk back and forth. When it's you and 10 people, maybe you need a little bit better way to broadcast information. When it's you and 100 people, that's getting to be really difficult. And then 1,000 people, it's like that's when you have layers and layers of middle management trying to just get everyone on the same page somehow through magic. I don't even know how. But that's especially important for like open source libraries, I think, where when you write an open source library, I would lean far more on like the constraints and automation side of things, where it's like, if someone's using an open source library, I don't want to depend on them calling A, B, and C in the correct order. I just want to give them a good default where they always do it correct, because otherwise they're going to mess it up. I mean, there was a library I still maintain, Jodatime Android, and for a long time, you had to call this one line of code to initialize it. And that one step got me more issues on the bug tracker than anything else, because people would just forget to do that one step. Not like I didn't document it or anything, but once Android started providing a library that allowed you to like automatically initialize your own libraries, I just went that way and never looked back. Because it's like, okay, this is one fewer step for people to mess up. And I think that's time. Thank you so much for coming to hear me jabber on for an hour, or 45 minutes.